Centrifugal pumps. Talking about the pumps, we always come across to the centrifugal pumps. Their uses can be seen in water, sewage, petroleum, and petrochemical pumping. Now the question is, what is centrifugal pump? A centrifugal pump converts mechanical energy from a motor to the energy of a moving fluid. A portion of the energy goes into kinetic energy of the fluid motion, and some into potential energy, represented by fluid pressure or by lifting the fluid against gravity to a higher altitude. Or we can say a centrifugal pump is a rotating machine in which flow and pressure are generated dynamically. Now let's understand the principle of centrifugal pump. The centrifugal pump creates an increase in pressure by transferring mechanical energy from the motor to the fluid through the rotating impeller. Fluid enters the pump through the eye of the impeller, which rotates at high speed. The fluid is accelerated radially outward from the pump casing. A vacuum is created in the impeller eye that continually draws more fluid into the pump. The centrifugal force hereby increases the fluid velocity, and consequently also the kinetic energy is transformed into pressure, which in turn lifts the fluid against gravity. The energy created by the pump is kinetic energy, according to the Bernoulli's equation. Now let us see the important components of centrifugal pump. Impeller. It is a wheel or rotor which is provided with a series of backward curved blades or vanes. It is mounted on the shaft, which is coupled to an external source of energy which imparts the required energy to the impeller, thereby making it to rotate. Casing. It is an airtight chamber which surrounds the impeller. It is similar to the casing of a reaction turbine. Suction pipe. It is a pipe which is connected at its upper end to the inlet of the pump, or to the center of which is commonly known as eye. The lower end of the suction pipe is dipped into liquid in a suction tank or a sump, from which the liquid is to be pumped or lifted up. The lower end of the suction pipe is fitted with a foot valve and strainer. Delivery pipe. It is a pipe which is connected at its lower end to the pump, and it delivers the liquid to the required height. Just near the outlet of the pump on the delivery pipe, a delivery valve is provided. Now let us move to the working of the centrifugal pump. The first step in the operation of a centrifugal pump is priming. Priming is the operation in which the suction pipe, casing of the pump, and a portion of the delivery pipe up to the delivery valve are completely filled with liquid, which is to be pumped, so that all the air from this portion of the pump is driven out and no air pocket is left. After pump is primed, the delivery valve is still kept closed and the electric motor is started to rotate the impeller. The delivery valve is kept closed in order to reduce the starting torque for the motor. The rotation of the impeller in the casing full of liquid produces a forced vortex which imparts a centrifugal head to the liquid and thus results in a centrifugal head and thus results in an increase of pressure throughout the liquid mass. The increase of pressure at any point is proportional to the square of the angular velocity and the distance of the point from the axis of rotation. Thus, if the speed of rotation of the impeller of the pump is sufficiently high, the pressure in the liquid surrounding the impeller is considerably increased. When the delivery valve is opened, the liquid is made to flow in an outward radial direction, thereby leaving the vanes of the impeller at the outer circumference with high velocity and pressure. At the eye of the impeller, due to the centrifugal action, a partial vacuum is created. This causes the liquid from the sump, which is at atmospheric pressure, to rush through the suction pipe to the eye of the impeller. As the liquid flows through the rotating impeller, it receives energy from the vanes, which results in an increase in both pressure and velocity energy. The shape of the casing is such that the leaving liquid flows through a passage of gradually expanded area. This change in shape uniforms the kinetic energy of the fluid.